There's a strong connection actually between prions that can remain in the environment for over a decade and water. Because the herd had a high positivity rate, there was a lot of prions put into the environment. So you can imagine the concern of environmental contamination where this stream is flowing through the dump site and then running into these wetlands just outside the fence.
We started off at the very beginning. A prion is unlike other aspects of water contamination. In some ways, there's a lot of basic research that we needed to do to even think about where or how this prion might move in water.
The first step in tackling waterborne transport of prions was figuring out how prions are going to travel within a waterway. For example, some contaminants in the environment more readily bind to sediments and are carried with particle transport, and some are dissolved or free-floating. And coming into this project, we just didn't know that about prions.
In sort of like soil and environmental sampling, what we often do like this is like lay a line in a transect, and then we will sample at every like meter point along it and put that all together in one bag, because then we feel that's like representative of this area.
We used samples from the environment of water that also contains sediment. We added prion-positive deer tissue to those water samples and then separated the water and sediment via filtration, and then ran it through our detection assay for prions. What I found was in most cases, the water component did not have prions in it, or very rarely had prions, while the sediment component nearly always had prions. So this led us to an initial conclusion that prions are more likely to be bound to particulates or sediments in the water rather than be free-floating in the water itself.
What this does is helps us work with water quality managers and water managers to narrow their playbook. An analogy would be in American football. You can have a rushing ground game, or you can have an air game where you're throwing passes. How the defense is going to work wants to know what they're up against. What we have found with the sediment-associated prions lets us narrow what we're up against.
Now that we know that prions are most likely to be bound to sediment, our next step that we need to determine is how those transport rates will vary regionally. Different parts of Minnesota have very different soil and sediment characteristics, and also very different rates at which water flows through them.
The soils, the waters, the landscape from the southeast to the northwest of Minnesota are very different. Part of those differences are reflected in the chemistry of the water, of the soil, and the shape of the landscape. All of those physical factors and chemical factors can lead to differences in CWD, binding behavior, persistence, and mobility. We can now go to the next layer to quantify and assess persistence, time of downstream risk, movement, etc.